Hey, my name is Alexa Carpenter, and we are going to talk about the Galaxies lecture. There's a couple things we're going to start off first, just the basic information, one of which is dark matter, which I didn't really know before. I decided to look it up, and I figured out that we know there's dark matter due to its gravitational effects on visible matter, radiation, and large-scale structure of the universe. I also learned that dark energy is constant throughout space, and there's a finite amount of dark matter that began at the beginning of the universe. We also know that dark energy becomes more dormant throughout time. So from that, we know that 90% of the stars that will ever form have already formed. In a time scale, the Milky Way is 2.4 million light years away from Andromeda, which is the closest galaxy. In terms of seconds it takes to see light from these places, it takes 1/3 of a second from the moon to us, 8 minutes from the sun to us, and 2.4 million years to get to Andromeda. Also, in order to figure out where galaxies are and how far away they are, we can analyze the wavelength stretch from the galaxies, and that will help us determine where they are. So now we're going to move on to the very first stars. We see that the first stars were formed as hydrogen gas cools and dark matter fluctuates and collapses to form mini halos. And these mini halos are kind of like the basis of all the galaxies because these mini halos are the hosts to the first stars, which happened about 1 million to -3 million years ago. They form rare peaks in dark matter halos, and if there's enough halos, they will form a galaxy. And one of the other things that we have found out is that the more massive the star, the faster it burns. So due to this, the first stars had to have been massive, so they wouldn't exist anymore today. So we have to kind of look back in time to figure out when they did exist. And we know that it also takes hundreds of millions of years for gravity to create these halos, which will explode in a tremendous supernova. When these supernovas exploded, they blasted out metals, and this enriched the first galaxies, which were the building blocks for all the present-day galaxies. We've seen that a lot of the more recent stars contain a lot of metals, and if you look into the past stars, they didn't contain quite as many metals. So we know that from the recent supernovas and the galaxies that have formed due to those, more metals have formed. We see that a majority of the first galaxies will merge into larger systems. They don't just stay in their own little world. The gravitational force of each galaxy will cause it to collide with any other galaxies. So we also know that that means that our galaxy will collide with the closest galaxy, which is Andromeda. So the Milky Way is predicted to collide with Andromeda in 4 billion years, which in the scheme of things really isn't that far. We got to see a cool video about the Milky Way colliding with Andromeda and just forming a bigger galaxy, which I thought was really fascinating. So overall, I really enjoyed this lecture. I learned a lot, didn't really know how stars would form or galaxies or any of that, and I definitely didn't really understand dark matter. So I found that really fascinating. So I hope you enjoyed this video. I hope it was a little helpful, and have a good day.